Am I audible?
Yes, sir.
Okay. So the last lecture was all about quadratic equation, and we derived the formula, right? So if ax square plus bx plus c equals to 0, where a is bound to be non-zero number, then the x turns out to be how much? Minus b plus minus under root of b square minus 4ac upon 2a. So now b square minus 4ac having a special name, what we call this number, or this entire term? We call this term as,
So determinant.
no, it's not determinant, it is something else.
Discriminant.
Discriminant.
Oh yes, sir, discriminant.
So discriminant is a simple word which means discrimination, right? To behave differently. So this will differentiate or discriminate between what? Between what? So this is supposed to discriminate between roots. What is roots? The roots are also called zeros of equation. Or you can say solution to the equation. So this is very, very important to understand what is discriminated and how it is going to discriminate between the roots. Okay. So the value of the D will decide the nature of root. So D decides nature of roots. So how it is going to discriminate or decide like how the roots are going to be. Okay. So every quadratic equation will have solution, and the solution are nothing but the roots of the equation or the zeros of the equation or the values of x which satisfied the equation. You can say in the way you want. So roots or zeros or the unique values which can satisfy the given equation we call the roots. Okay, it's all the same thing. And how D will decide? So D will decide by its value. So D comes under root, right? And we know that. Can we find the root of negative number? What is the value of minus 3? Can we find it?
No.
No. So this is like a non-real number. Which means we are not going to get any realistic answer. It will have some imaginary answer, and that imaginary answer will have its own interpretation. We call it complex number, which is a better way of saying it. So it's not a regular real world, it's a complex world. So if D is a positive number, we'll start with the negative. If D is negative number, what does it mean? It means we cannot calculate the value of this, which is root D. And because root D is not defined in a real scale, or you can say real number or anything real. So if D is negative, it means the roots are going to be, what do we call?
Imaginary.
Imaginary. I mean, because the roots are not going to be on a realistic scale. So we say roots are going to be imaginary. So a negative D will give you property of roots, and it will tell you that roots are imaginary. And there is a special mathematics which is defined for such numbers which we call complex number. And then again, complex number itself is a complete theory. So -1 is denoted by a symbol I, and that is called iota. Okay. So there's a special symbol for it. -1 we write as I. And if you square both sides, we call it I square. And the moment you write like this, the negative number, you can write as I square into 3. And therefore, this you can rewrite as √3 into iota. So this way of writing is called complex notation. Complex notation. And anything which we write as a coefficient of I, it is called the coefficient of complex number, or you can say the imaginary part. This is the √3. See, √3i is imaginary, but √3 is not imaginary. √3 is called imaginary part. In general, any complex number, let's call it Z, which is a very general notation for it. So Z is a complex number, and this we can rewrite as some number which is real plus or minus some number multiplied with iota. This is the way of writing. So if you add real and complex, the final answer is complex, because something known and something unknown, if you add up, eventually it is unknown, right? So real plus complex will eventually give you complex number. A may be 0, A may not be 0. So if Z is complex number, what does it mean? The B must be. If Z is necessarily complex, then what we can say? B must be non-zero, right? Because if B is 0, then I will do nothing. So 0 into I is 0. So this leads to a concept called complex number is superset of a real number. Why? Because every number which we write in this format, if I make B equals to 0, I'll get a real number. So every real number can be written as, so if we have 3, can we write 3 as 3 plus 0i? Because it will not make any difference. So every real number is complex, but every complex is not a real number. So real number is a small world, whereas the complex number is a bigger world. And you will understand these things when you study calculus in mathematics. You will come to know that the world of a real number is a very tiny world inside even a bigger world called complex number. So it's really huge topic, and maths will take care of all this thing. So anyway, so when D is negative, what we infer is the roots are going to be imaginary. Okay, but more than the mathematical definition, what is important is the physical meaning of it, or the graphical meaning. So we'll try to understand the graphical method, graphical meaning of it, than just a physical meaning, mathematical meaning. So graphical meaning. So if a D is negative, This implies the roots will be, so let alpha and beta are roots of quadratic, then alpha and beta will be complex number, and it will never intersect the real axis. So it will means the graph will, how the graph will look like? Can you guess? Anyone? How the graph will look like? So this is the x-axis, and the meaning of root is that the quadratic graph, which we'll learn later on, that if you if you plot a quadratic graph, there are two types of quadratic graph. It is either like this or like this. Now, if you have something like this, and if you extend, it will eventually cut somewhere. So this cannot be the answer. So the other answer possible is and the graph you can extend like this. Now, no matter wherever a graph goes, it will never ever intersect the x-axis. Can you see it is intersecting? No. Look at this one. This will intersect x-axis, yes or no? This will intersect. Hello, hello. This graph will intersect x-axis, yes or no?
No, sir.
So,
So that is the meaning of complex roots. Complex means there is no connection between the graph and the x-axis. They never meet each other. That's a, you can say, geometrical meaning, that they never meet each other. Even if you extend the graph up to infinity, it will never ever meet the x-axis. And therefore, there are two possibilities of graph. The first possibility you will get if a is a positive number, and the second will get when a is a negative number. So this is a positive and d negative. This is a negative and d negative. So these are the two graphical meaning when roots are imaginary. So if you try to plot it, it will look like this. Okay, upward parabola or downward parabola, where a is positive, then it is upward, and when a is negative, it is downward. So this graphical thing again you will learn in mathematics. No need to worry. But you must understand that in mathematics, every result can be interpreted in terms of graph. Okay, so I'll try to take one separate lecture for graph, with how to plot the graph, how to think about graph, and so on. But as of now, just remember this thing, that if roots are imaginary, if d is negative, graph will fail to touch the x-axis. That's it. So this is how the discriminant, as the name suggests, it is going to discriminate between the roots. It is going to tell you the behavior of roots based on its own value. So now the next question is obvious. What will happen if d is positive? If d is positive, then what will happen? Tell me, guys. The root of d will be real. And if you add a real number to any real number, what will happen? So real plus real is always real, isn't it? So
Yes.
addition or subtraction of two real number is a real number. And if you look at the answer, which is minus b plus minus under root of d by 2a, what we are doing in the numerator? We are adding two real numbers or subtracting two real numbers isn't it? And because both are real, the answer is going to be real. So we can say alpha and beta will be real. Okay. Now in the real case also we have a, so real is a big number. Real is a big domain. So it's like this. In the world of complex number, if I say this is complex world, this is your small real world. And inside the real world, there are two separate worlds. One is called irrational, and the remaining is a rational world. Okay. So what is irrational? I hope you might have heard about the word rational and irrational. What is irrational? Tell me, guys.
So, in the form of IQ.
Yeah, a number is said to be irrational if it cannot be expressed in terms of p by q, where p and q are where p and q are integer.
Integer.
Very good. So any number, if it is irrational, it cannot express as p by q, where p and q are integers. So you can see the complex number is the biggest world that we come across. And then the real domain is a small world within the complex world. And within the real world, we can have two separate worlds, rational and irrational world. And the irrational is for those numbers in which the perfect square is not possible. So we cannot express d as a perfect square. Okay. So if alpha and beta are real, it will have again two possibilities. Rational and irrational. So when it is rational, when d is perfect square. So let's say if d is 4 or 9 or 16, 25, 144, 169. Okay. So if we have number like this, it will be perfect square, which we can take it out of the root, right? And because it is without the root, eventually we can express without root. Then this will fall into the category of rational number. And if d is not a perfect square, then the number will be irrational. So when d is positive, then there are two possibilities. The roots may be rational or roots may be irrational. Now, in this particular case, if the root is rational, then again there are two possibilities. So we'll see the other possibility. So I am particularly interested in the irrational roots. If the root is irrational, if roots are irrational, they will have peculiar relationship, very nice relationship. You know what is the relationship? Can you guess? So alpha, if you replace, represent by minus b plus root d by 2a, the beta is going to be minus b minus root d by 2a. And what is the difference between these two roots? Can you guess? Only the sign between the two terms. So you can see something here. the sign between the rational and the irrational number is only different, and such numbers are called conjugate numbers. So what do we call this as? Alpha and beta are called conjugate pairs, which means they only differ in the sign between them. So when the roots are irrational, the only difference you can see is the sign, and they will always come in a conjugate pair. So if you know one answer, the other you can always guess. So the moment, let's say, if I tell you that if alpha is 2 plus root 3, and if this is the one of the root, the other root you need not to define or calculate or find. What will be beta?
2 minus
2
root 3.
minus root 3.
Very simple. So that is a property which you can directly invoke, and you can write the answer directly. That if alpha is known to you, the beta is going to be this only. There is no way out. Okay. Okay. So the last discrimination it can do is when D is 0. What does it mean? Can you guess when D is 0?
When roots are equal.
It is like the discriminator has died. There is no one to discriminate. And if there is no one to discriminate, then alpha and beta will be equal, right? So in this case, roots will be real and what?
Equal.
Equal. So real will be there for sure, because there is no one to be under root of something. 0 is 0. And the roots will have no discrimination, because the discriminant itself is absent. So if there is no discriminator, we will never discriminate between the roots. They are going to be same. So alpha will be equals to beta. And in that case, the answer will be how much? Minus b plus minus root 0 by 2a. So alpha and beta both will be. So how many roots we have? 1 or 2? Tell me guys, how many roots we have here?
1.
Oh, so we call this is 2 roots. We have always 2 roots. Alpha and beta are the roots. So we call it repeated roots. Okay. And why this is again important? Every quadratic equation which you write as ax square plus bx plus c can be expressed in terms of roots like a x minus alpha into. If alpha and beta are equal, then so if alpha and beta are equal, let alpha equals to beta equals to t. In that case, the quadratic we can rewrite as x minus t into x minus t. We have to write 2 times. And so it will become x minus t whole square. So in case of equal roots, the equation will be still quadratic, and we have to write like this. If you say there are only one root, what will happen? X minus t will be there, but the other will have nothing. You're saying no, nothing is there. Are these 2 expressions same? Are they same or different? So these 2 expressions are different, no? The above equation is ax minus t whole square, below is only x into x minus t, which are quite different. So in such case, the word is used is called repeated roots. You are repeating the answer. Okay. Is this part clear, guys? Tell me.
Yes, sir.
Okay. Now, what is the physical meaning of this? Because this is again very important. If D is 0, what this reflect? The answer is real. It means the graph must be touching the x-axis. Okay. So D equals to 0 will have two interpretation. Either the graph is just touching the x-axis and leaving like this, or the graph may be like this. And you can see the x-axis and the graph is only touching at one point. Therefore, this is representing the repeated roots. We don't have two roots, we have same root repeating at the same place. Therefore, graphically it looks like one. And what is the difference between these two graphs? When will be the graph upward? Can you guess? The upward graph we will obtain when the a of the equation is positive number, and below will be when a is negative. So if the coefficient of x square is positive, it will have upward parabola. We call this as parabolic graph. And when a is negative, the graph will be downward parabola. How to represent the D positive graph? How we are going to represent the D is positive? Tell me, guys. So what if the D is a positive number? We are going to get how many answer? One answer, two answer, no answer. One answer, two answer, no answer. How many roots we will have? So we will have real and distinct root, right?
Yes,
Real and distinct, which means two separate values. And because it is there are two values possible, so we will check or we will see that there are two cut on the x-axis. So graph may be like this because it is meeting the x-axis twice, and the number of intersection is called the number of roots. And again, it may be like this. So we can call this as alpha, this is beta, alpha comma 0, beta comma 0. Same you can add here also. And again, the upward parabola will refer to which condition? Tell me, guys. When we draw the upward parabola.
Then A is positive.
And what is A? Coefficient of
x square.
x square. And this will have the graph when A is negative. Okay. But there are many more things you can actually conclude. So in the first graph here, look at the graph here, everyone. Very careful. This is part of the physics. What you can see, the graph is either at this point or above this point. So what is the lowest value of graph? This point is the lowest value, correct? So this point is called minima of the graph. This point is the minima, this point is the minima, and this is the minimum value. This point is called minima. So at this value of x, the graph will attain the minimum value. Do you realize this? Hello, hello, hello.
Yes, sir.
So at this point, the graph will be minimum, which means the quadratic will, the entire expression, if you put this value of x, the expression will give you the least possible value. Okay. So that is why this is called the minima. So when a is positive, we can only obtain minima. Can we obtain maxima or the maximum value? The answer is no, because the graph will go to infinity. So there is no finite maxima, but there is a finite minima. This is called the y minimum. But if a is negative, what we are going to get?
Maximum value.
We are going to get maximum value. Which means at this value of x, let's call it x naught. So at x naught value, the graph will obtain its maximum value. It means in the quadratic expression, if you put x equals to x naught, it will give you the maximum possible value the graph can attain. So by looking at the sign of a and knowing the discriminant d, we can always guess whether we are going to get maximum or minimum. Is this clear? Hello, hello, hello. 1, 2, 3, 1, 2, 3.
Yes, sir.
Yes, sir.
Okay, so we'll do some practice, some graphical practice to understand that how in physics these equations will actually look like. So let's say I am giving you the equation y equals to what? Ax minus bx square. Ax minus bx square. Look at this term. Is this term quadratic? Yes or no? Can you see the term and tell me whether it is quadratic or not?
Yes, sir, it is.
Very good. So ax minus bx square is quadratic. Let's say a and b are positive numbers. So this is the underlying assumption. So can you tell me the coefficient of x square is positive or negative?
Negative.
Very good. So this graph is representing what? Upward parabola or downward parabola?
It's a downward.
Very good. So this is representing downward parabola. Okay. So one thing is clear that it is going to be something like this. Correct? So because it is downward parabola, are we going to get maximum or minimum?
Sir, maximum value.
Maximum.
Very good. So now this graph will give you some maximum value. Correct? This graph will give you some maximum value. How to calculate that value? How to know that that point is having maximum? Any guess?
Sir,
So
is
how
it the
to find?
midpoint of alpha and beta?
Yeah. So it is the midpoint.
Coordinates.
Yeah. So it is the midpoint of alpha and beta, which is like alpha plus beta by 2. So the point x naught must be how much? Alpha plus beta by 2. Yes or no?
Yes, sir.
For any, I have taught you in the how to find the midpoint of two numbers. So if we have x1, y1, and if we have x2, y2, in vector we have done. No? So the midpoint formula is what? X1 plus x2 by 2 and y1 plus y2 by 2. Do you remember this midpoint formula?
Yes, sir.
So in any quadratic, tell me what is the sum of roots?
B by A.
Minus b by. How to get the answer? Why this is the answer? Let's compare it. So if we write this, if we expand this expression, x into x square minus alpha plus beta into x. Okay, guys. Now on the LHS we have, let me take a comma. And on the RHS we have x square minus alpha plus beta into x plus alpha into beta. So if you compare each term, the first term is matching, fair enough. What is the b by a here? B by a is minus of alpha plus beta, correct? Compare the term by term. And c by a is alpha into beta. Can you see that?
Yes, sir.
So what we realize from here, the summation alpha plus beta is how much? Minus b by a. And alpha into beta is how much? C by a. So the sum of the root is minus b by a. What is minus b by a? From the actual quadratic equation, not for this equation which I have given. So if we write the quadratic as ax square plus bx plus c, then the sum of the root will be minus b by a and the product of the roots will be c by a. I hope you, this is not difficult, or is this difficult? Is this okay?
Yes, sir.
Anybody finding it difficult? Tell me. No. Yes. All right. So therefore, the maxima or the minima we obtain at which point? So can we write this as minus b by a by 2, which is like minus b by 2a? So the point at which either you will get the maxima or minima will be this point. Correct? Okay.
So I didn't understand why you divided alpha plus beta by 2.
Ah, that's good point. So what is the coordinate of this point? Alpha comma 0. What is the coordinate of this point? Beta comma 0. So the graph is symmetrical. So the minima will be at which point? Exactly between these 2 points, isn't it? For any symmetrical graph, can we say that this is graph is symmetrical? So the maxima or the minima will be at the midpoint of these 2 points?
So, but that would be on x-axis, right?
Yeah, yeah. So this is the x naught, no? This is the x-axis.
Okay.
This is the point at which you will get the minima. This is not the minima. It is like a location. And the value is here, no? This is the value. At x naught value, the graph will have the minima. So it's like if you walk at location x naught, you can see the trough exactly below you, right?
Yes.
So x naught is the location, it is not the minimum value. Okay, there are 2 things. One is the location at which it is minimum, and what is the minimum value. So we obtain the location first. We are trying to find the location. Understood? I think it is still not clear. Look
So
at this.
clear.
Okay, very good. So now let's come back to the problem. Okay, what you are supposed to remember is, you are supposed to remember 3 things. First, sum of the root is minus b by a. The product of root is how much? C by a. Okay. And the third thing is, every quadratic equation, if no alpha and beta are roots, can be written as a times x minus first root into x minus second root. Is this clear? Okay, I will tell you the simple thing. So there is something called factor theorem, you can say. If alpha is a root of any equation, then x minus alpha must be its factor. Understood? If alpha is any root of any equation, then x minus alpha must be its factor. So if alpha 1, alpha 2, dot 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 alpha n are roots of any equation, let's say it is polynomial equation, I don't know how much, what is the degree, then x minus alpha 1 comma x minus alpha 2 comma and dot dot dot, these are must be its factor. Okay. So that's a simple thing. This is how we write. So if you know that alpha and beta are factor or the roots of the equation, then x minus alpha and x minus beta must be its factor. That's the factor theorem. Again, you will study in mathematics, don't worry. So every quadratic can be expressed like this. And what we do is we always make the coefficient of the highest power 1. So you have to take a common. And once you take a common, the remaining we can factorize like this. And again, I re-multiplied and then I showed you that the sum of the root is this much. And the if you want to go through the formula, you can add and check. Okay. So the answer we have in quadratic is minus b plus minus root d by 2. Tell me what is alpha here, minus b plus root d by 2. Let's make it small. So if I call alpha as minus b minus root d by 2, and if I call beta as minus b plus root d by 2, then tell me guys, what is alpha plus beta by 2? So what is alpha plus beta? Tell me. If you add, what we get?
minus 2b by 2a.
Yeah, so minus b by a, correct. And if you multiply these two root, what we get? Minus b whole square minus root d whole square. A plus b into a minus b is a square minus b square upon 4a square. So b square minus d. And d itself is how much, guys? So 4ac by 4a square. What is the answer? C by a. You can also obtain like this. There are many ways of doing this. But factor theorem is very powerful theorem. So if you study maths, you will come across anyway. No need to worry. So if you know that someone is root, then x minus that will be always a factor. It means we can decompose the given equation into two smaller order polynomial. Okay. So quadratic is having the highest power 2. So it will be decomposed into linear equations. And that is what we are getting because each term is linear. Okay. So in quadratic we have linear. Okay. Tell me if you have doubt so far here. Any doubt? Coming back to the same problem. If y I am writing as ax minus bx square So what is the kind of graph you're going to get? Upward parabola or downward parabola? Tell me.
Downward parabola.
So we are going to get maxima or minima?
Maximum.
Maximum.
Maxima. Can you plot the graph accurately? In fact, you can. How? So to plot the graph, you simply write when y will be 0. How to plot? So as a beginner, you can just write find when y will be 0. And if you put y equals to 0, this will give you ax minus bx square equals to 0. And I can take x common, so I get a minus bx. And it's a 2 factor. I will equate both terms separately. So either the first term is 0 or so the y will be 0 at two possible values, one at 0, another at a by b. And we know the graph is inverted parabola. So it will have two roots. And it will pass through these 2 points. So in mathematics, you can extend like this. In physics, we only draw a part of the full graph because physics is all about real world. So y negative means you're going into the ground. So let's say if we don't have the space to go inside the ground, then such graph we have to. So we draw the full graph and then we eliminate a part of it. And we keep only a small part of the graph because that is meaningful to the real world. So mathematically, it is the full graph. In physics, we have to discard the part which is not feasible in a realistic world. And anyway, if this is 0, this is a by b, where you can expect the maxima? At, now this is
A by
pretty easy,
2b.
na? A by 2b. But the formula also says the same, minus b by 2a. But luckily, what is b here? Here b is a. And what is a here? Minus b. Do you realize this? This
Yes,
is the
sir.
formula. The a is called the coefficient of x square, which is minus b. And b is called the coefficient of x, which is a. And if you do the same thing, you get the same answer. Now, if I want to know the maximum height or this maximum y value, how to get this answer? What is the maximum value of y? So it's very simple. In the given formula, put x equals to the location when this is possible. So in the expression, substitute x equals to a by 2. So a into a by 2b minus b into a by 2b whole square. So a square by 2b minus a square by 4b, and this answer will be, this is answer. So what is the maximum value of y? You can see here, just a minute. So the y maximum is a square 4. There are many, I mean, we can do it by formula also. So how to do it by formula? That the y maximum. Can you guess how to get the y maximum? Again, it is very simple. You can do multiple ways. The maximum is possible for y maximum. The answer we got is how much? The x value is how much? Minus b by 2a. I hope you remember. Minus b by 2. This is simple way to remember. And if you substitute the value in the actual quadratic equation, which is ax square plus bx plus c, where x equals to x naught, and there are many other ways also. I mean, this is simple way. You can write as a into minus b by 2a whole square plus b into minus b by 2a whole, I mean, something like this, plus c. And then this will lead to the answer a b square by 4a square minus b square by 2a plus c. How much is this? B square by 4a minus b square by 2a plus c. So minus b square by 4a plus c, which is minus, I'll take common, b square 4a minus, and this is b square minus 4ac by 4. And now if you look carefully, what is the numerator? So the numerator is the discriminant, right? Correct?
Yes.
So the maximum value is always the discriminant minus of discriminant upon 4a, and you may be wondering why minus, because a itself is negative, so minus will make it positive actually, because maxima is only possible when a is negative. We have seen this, right? The parabola must be downward parabola. Okay, so I'll give you some other way of thinking. There are many ways in which you can think. So we will revisit the same formula, but in a totally different perspective. So how to decode the mathematical formula into realistic world. So let's say you gave me the equation y equals to ax minus bx square, and with the help of the plotting, I know this will be something like this. Do we need to remember all these things? The answer is no. I mean, in fact, I never remember anything. So we realize that this is 0 and this is a by b. It could be any value. But look at something interesting. In this graph, every height is traversed twice. Can you see that? So this height will occur here and here both. Correct? Here and here both. You can check every height is happening twice. Yes or no? So in this graph, the y value, this height is repeating twice. So which height is repeating only once? The maximum height, isn't it? The maximum height is repeating only once. Do you realize this?
Yes, sir.
So if I put y equals to this small h, I must get two answers here and here. If I put this as h dash, I must get two answers here and here. If I put h double dash, the answer must be same here and here. But if I put this h max, just a moment. So every height is repeating for two possible values of x, but the maximum height only occurs once. So if I write, or in fact, I will say rewrite the formula in terms of quadratic, it would look like bx square. So can we rewrite like this? Bx square minus ax plus y equals to 0. Now this is a very nice quadratic way of writing the same equation, right? Okay. And if I put y equals to h max, the x must be unique answer. Yes or no? So this quadratic will have how many roots? So this quadratic will have two roots for every height except the
Maximum height.
maximum height. Do you realize the meaning of roots? The roots means there are two possible answers for every height, but there is only one answer for which height? Maximum height. Yes or
Maximum
no?
height.
If you realize this part, then I will show you something really interesting. Since when y is y max, then roots must be equal, because we want only one answer. So when we have only one answer, when roots are equal. And tell me guys, when roots are equal? When discriminant is
0.
very good. And how to write the discriminant of this quadratic equation? Tell me. B square. What is b square? What is b here?
Minus a.
So b is minus a whole square minus 4. What is a here?
B.
And what is c here?
1.
Y. The y itself is c, na?
Yes, sir. Y.
And if you rearrange, you will get the answer y equals to a square by. And this is the maximum value, right? This was the answer. I think we got the answer somewhere. Yeah. The a square upon 4b. There are many ways to achieve this because it's quadratic, so it will have many beautiful properties. It is symmetric, it is either upward or downward. It will have either a maximum or the minimum. Okay. And then this is the other way of thinking, that if I convert the given equation into quadratic, I know that the maximum will only happen once, and therefore if I do this, I'll get the answer. Okay. So when in kinematics chapter you are studying, let's say, projectile motion, okay, and if I give you equation of trajectory, so there's something called equation of trajectory, and don't worry, I'm going to write a big formula in which I write y equals to x tan theta minus gx square upon 2v naught square cos square theta, where x is variable. So here it is only x which is variable. The theta and the velocity, everything is g, everything is constant. So x is variable. And if you look carefully, are these two questions similar? Does it look same?
Yes, sir.
So can we write this as ax minus bx square, where what is a representing?
Tan theta.
Very good. What is B representing?
G by 2 V naught whole square plus square root.
Very good. And if you remember, what is the Y max we got?
K square by 4B.
So if I substitute a square, which is tan square theta by 4b, which is g upon 2v naught square cos square theta. And now you can see this turns out to be v naught square sine square theta by 2g, which in fact is the maximum height formula. If someone has studied the projectile motion, can vouch for it. If not, don't worry, because we are trying to look through the lens of mathematics, not physics. So in physics, when you obtain any equation, then try to isolate the world of physics and bring that equation into the world of math and try to do the mathematical manipulation. And this act, I mean, or you can say this skill of understanding when to apply the mathematical formula or mathematical intuition in physics will facilitate your mathematical process a lot. So this is where we get stuck. Like, we don't see quadratic when it is in physics. We see quadratic only in mathematics. And that is my concern. I mean, I am trying to develop this habit that please don't see both in isolation. So many a times not many, like in almost every time, students are very much comfortable in the mathematical solution. They know how to solve quadratic. The same equation coming in physics, they don't see the quadratic at all. So they have no sense of quadratic in physics, but they have very good sense in mathematics. And I'm trying to bridge the gap. Don't see both separately. And that is my purpose of teaching maths. It's not about these things are not taught in maths. Everything is taught in maths. But in maths, what we don't get is the connection. How the world of physics, how the equations in physics are totally depending on the world of maths. So please try to develop this habit that see the equation as a mathematical expression and also see the equation as some concept of physics and try to correlate the two worlds. And once you're able to do so, it's very easy. Now, of course, this question is from IE Rodov, which we just solved. Finding the maximum. And we are doing it without calculus. Of course, there are other methods. By doing calculus, we can differentiate and we can do something, which we will learn eventually. So for the world of quadratic, which is a very common word in physics actually. Okay, so I'll show you something very interesting from world of kinematics. So we will learn physics for sure, don't worry, but we'll try to understand how the mathematical intuition will help us tremendously. So imagine this is a tall building. This is a tall building. A building with balcony. You want balcony? Okay. Yeah, I'll make a balcony also. So which color balcony you want? Tell me. Any preference? Okay, no preference. Anyway. Okay. So don't worry, I'll make it balcony. No, it's fine. For safety precaution, I'm putting the tall height so that you should not fall off the balcony. And now, let's say you are standing here. Oh, that's too small legs. And maybe you are sipping your favorite coffee. Okay, and then your friend comes. playing with a ball. So we'll do some assumption. Let's say the height of your friend is very small compared to the height of the building. So I will ignore the height of the person, and the person will throw the ball. So we'll assume that person is throwing the ball from here, although I'm showing there, but assume like this. And because I don't have the space to do very big building, so assume it's a very tall building. And now you're throwing the ball with velocity v naught, and you're throwing really fast, like at a very high speed. So what will happen? Tell me. The ball will go to certain height, much more than your friend height, and then the ball will return back to the ground. Okay. So what is happening? So at some instant the ball will be crossing your friend. So when the first time the ball is crossing your friend, let's say if I choose the time of projection as t equals to 0, and when the ball is crossing your friend, if I call the time as t1, and then the ball will go up and will come down again. While crossing the same location, the time which you see in your clock is t2. Now t1, t2 we are measuring from beginning. So the t1 and t2 are the time at which the ball will have this height. So do you see quadratic here? Anyone? And if you see quadratic, then how you see it? Can I explain the meaning of quadratic here? Just the intuition part.
So I think that we get two values in the quadratic, and the smaller value is t1 and the greater value is t2.
Correct. Very good. And the time is corresponding to what? The height of the ball. So the t1 and t2 is corresponding to which height? The height of your friend from the ground level, isn't it? If you look at the height, the ball is going to a very big height, like it is going to much more than a friend height. Every height, the ball will cross twice. Yes or no? Once while ascending, other while descending. Do you see this?
Yes, sir.
So every height, whatever height you consider, will have two instants for sure. So can we say that the height must be a quadratic function of time? Can we say height must be quadratic function of time? Every height, any height, except the maximum. So can we say, guys, that height is a quadratic function of time? Yes or no?
Yes, sir.
And t1, t2 must be the roots of the equation
Yes, sir.
for your friend height, like this height, not for all height. The t1, t2 represents the roots of the equation for this particular height. How many of you are able to realize this? That if I call this height as h, which is unknown to me, your friend is only measuring t1, t2. Okay. And you call your friend and tell, ask that, okay, tell me the measurement, and he will tell you, see that t1 is this much and t2 is this much. The question is very interesting. Given t1, t2, can you find the height of your friend? So given t1 and t2, can we calculate height of A. Person A. So how to begin with? So of course, this is the question of actually kinematics. And this is the vertical motion or motion under gravity. So if you have studied in class 9th, you may write the equation S equals to, I'll just keep it simple as per the class 9th way of writing. S equals to ut plus half at square. And this is very much quadratic in time. I hope you must have realized this formula. So now what I'm trying to say is that try to see S equals to ut plus half at square as a quadratic equation in time. Can we see this? Very much you can see. Yes or no? The S equals to ut plus half at square. Are you able to see this as quadratic function of time?
Yes.
So earlier you might have seen the way you have seen. I don't know. I'm saying that can we change the perspective and we see as a quadratic only. Okay. And S is called displacement since beginning. So I'm looking for which displacement? H. And what is U here? V naught T. And what is A here, guys? If someone knows from, if you don't know, don't worry. But we can write A as minus G as of now. Because the ball is trying to go up and gravity is pulling down. So it is opposing, so it is decelerating. And the acceleration in case of gravity is G, right? So let's say, okay, I'm forcing you to believe that this is the right equation. So if you have not studied, don't worry, we'll anyway study of all those things. So can we reconvert this entire expression as a quadratic equation? No, don't look at this formula. Write as a quadratic by rearranging the terms and putting left and right. So if I try to write the same equation as a quadratic, how I should write? Tell me. Someone please let me know. What should I write here? I want to write this as a quadratic. So how should I write here? Write in a format ax square plus bx plus c and keep a as positive. Tell me guys how to write. Hello, hello, hello. Simply rearrange and tell me.
So half GT square
No, I
minus
don't want half and all because I want everything nice. Ax square plus bx plus c. If it is half, take LCM and remove it. I do not want anything in the denominator, just everything like a single line. The very standard way of writing quadratic. I want you guys to understand quadratic. The entire kinematics is actually based on quadratic. That's if you realize that the entire projectile motion or entire kinematics, it is 80% quadratic equation. So if you know quadratic and if you can play with quadratic, you can actually play with kinematics. And that is how I want you to understand the physics. Understand where the maths is important, where physics is important, how to bind the two ideas together and not look at it in isolation, because that is the problem that I have been observing for years. So you guys are, kind of wired to think that way. Your brain is kind of wired to think in that way. You see maths as mathematics, physics as physics, and what I'm trying to just bring it together. So can you write this into quadratic? Siddhant, tell me.
Yes, sir. So GT square
Yeah.
plus
Is it plus or minus?
GT square minus 2 V naught T and plus 2H.
Very good. Now this is my nice quadratic equation, which is very much in the format of ax square plus bx plus c. So how many of you are able to see the a, b, and c? And if you are able to see, then tell me what is a, what is b, what is c. Rugved will tell me what is a. What is A here?
G
And b
minus 2 V naught and
and
C
c.
is 2H.
Excellent. So nice. And what is given to you in the question? The roots of the equation, isn't it? The roots are anyway known to you in advance. And what are the roots? Tell me guys, what are the roots of the equation?
T1 and T2.
Excellent. You know the roots in advance. So how to relate the roots with the equation? The moment the roots are given to us, the moment we know the equation also, the simplest way to relate is the sum and the product. Always start this fashion. Don't try to solve the quadratic. We have equation of quadratic. We have the roots known to us, and we know the sum and the product of roots as a formula. So going back to quadratic, tell me what is the sum of the roots? Tell me guys.
Minus b by a.
So here, what is minus b and what is a? Like what is minus b by a? What is b here?
Minus 2 v naught.
What is a here?
G.
Excellent. And what is the product of the root?
2h by g.
C by a. What is C by a?
2h by g.
Excellent. Oh my God, you got the answer. The h is actually g by 2 t1 t2, right? Oh, so the moment you know the roots, you know the height of your friend. And not only that, you exactly know with what speed the ball was thrown. So with what speed you threw the ball? G by 2. See, this is not possible to solve only by knowing physics. I want you guys to really understand maths. And please don't make maths as a boring subject in which you only mug up the formula. Try to always extract the physical sense of mathematical formulas. So when you're learning quadratic, what is the physical meaning of roots? In fact, math is so much, you can say, realistic that the moment you start visualizing maths, you will fall in love with physics automatically. So physics is a way to see the realistic picture of maths. In a way, physics will help you in actually looking at maths in a better perspective than only learning maths without the perspective or taking that maths as something like a formula. No, please don't see that in isolation. And this is actually a very challenging problem. Like the question which you solve is actually challenging problem. It's not easy one. It is the level 2 problem. And what we are doing is we are trying to see the lens of maths and physics both. So physics will give you the expression. And once you have the expression, rest is maths. So this way of thinking we have to develop. Is this clear? Hello, hello. In fact, you can also tell me the maximum height. What is the maximum height in this case possible? The maximum height is the height at which the quadratic will have only one root, isn't it? So at what time you will reach the maximum height without learning, kinematics? Can you find the answer through mathematics, through concept of quadratic? Tell me guys. So when we will reach the maximum height, tell me. every height will happen for 2 instant of time, but maximum height will occur only at
Sir, one instance.
only one instant. So when h is h max, then we said the discriminant must be when you get the single root,
0.
you get the single root when the discriminant is 0. So we can say that for h equals to h max, not in, I mean, that height, the maximum height is only possible when the quadratic will have 0 discriminant. Why? Because when d is 0, we know only one root is possible, so t cannot have two values. Can we go to the maximum height twice in the entire journey? Tell me. Can we go to this point 2 times?
No.
If we can go to 2 times, it must not be maximum height. It must be something less than maximum. Yes or no, guys?
Yes.
Okay. And therefore, if d is 0, what does it mean? B square, now coming back from here, b square minus 4ac is 0. What is b, guys, again?
Minus 2 V naught.
Whole square. What is a? What is c? So you can clearly see that the h max is basically 4 v naught square by 8g, which is nothing but v naught square by 2g, which in fact is the maximum height. We know it. And if you want to write the answer in terms of time, we have the v naught here. So if you want to write it in terms of time, we can write v naught equals to g square by 4 t1 plus t2 whole square upon 2g. And that's very interesting answer. In fact, we can write the maximum height also in terms of time. Okay. Hello, hello, hello. Is this part clear, guys?
Yes, sir.
Yes.
And see, what we have just solved is the one of the most challenging problem of kinematics. And for that, we do not need to know kinematics. We just need to know how to play with quadrate. I'll show you some more questions just for practice. So let's say you're solving a question in which the question is called motion in one dimension. So the object or the particle will be moving along one particular direction. Let's call it x-axis. Okay. And the beginning point of the journey so this is some tiny object, and at t equals to 0, you're located at a point. Let's call it 5 meter. Just and the initial velocity given to this object is, so you throw with a velocity, let's say 10 meter per second. But some wind, the gust of wind is moving left. It's a heavy storm. So although you have thrown with 10 meter per second, But the retardation, because the wind is moving against this motion, we call it retardation, is 2 meter per spin square. Okay. So now at time t, it will have some position. Let's call it x. So how to write x? Tell me, guys. What is the displacement here? So we can write a formula s equals to ut plus half at square. What is s, guys? Tell me. What is s here? What is the displacement from 0 to time t? Come on, you can tell me the displacement. Hello, hello, hello.
So x minus 1.
Very good. What is u here? 10 t plus half. What is a here?
Minus 2.
Very good. So we can clearly see that x we can write as 5 plus 10t minus t square. So x is a quadratic function, yes or no? X is a quadratic function, yes or no, guys? Tell me. Hello, hello, hello. What happened? Am I not audible? Hello, 1 2 3 1 2 3.
Yes, sir. X is a quadratic function.
So x is a quadratic function in time t, correct?
Yes.
Now looking at the quadratic function, just now forget about the kinematics. Only look at the function and tell me, guys, in this quadratic function, the coefficient of t square, which is called a, is positive or negative?
Negative.
Negative.
So is it representing the upward parabola or downward parabola?
Downward.
So it will have maxima or minima.
Maximum.
Very good. So it means it will go to some value of x and it will turn back. Okay. So you will never be able to move on the right forever. So you will go ahead, and at some point it will, the object will turn back. Yes or no? Because the x cannot exceed this value. Okay. So if I plot the graph of x versus time t, where I represent x in the y-axis and this is the time axis. So as time will progress, so you are, let's say you are starting from here, you move like this, like this, like this, like this, like this, and then you stop, and then turn back. But how it will look on a time axis? So you are here at t0, but you are here at some other time. So it will look like this kind of graph, and you can clearly see that you cannot exceed this height or this x value. So if I want to know what is the maximum x I can achieve, what is the x max? What is the x max? So we know the maximum only happens at, for x max, the function must have the value how much? If you remember the formula, minus b by 2a. Only at this instant of quadratic, the x will attain the maximum value. I hope you remember.
Yes,
No?
sir.
What is b here?
10
What is a here?
minus 1.
Minus 1. What is the answer? which means when time is 5 seconds, the x will become maximum. And now we know the time at which it is maximum. What is the maximum value it can go up to? So minus 5 square plus 10 into 5 plus 5. How much is this? Minus 25 plus 50 plus 5. What is the answer, guys? So after traveling 30 meters, it will turn back. Later on, when you will study calculus, it's even easier, because calculus talks about differentiation. You differentiate, it will give you the answer 5. Very easy. But right now, since we are learning quadratic, so we are trying to look at the world through the lens of quadrant. Is this clear? Okay. Okay. What is the other way of solving? Let's say if you don't remember the formula, then how you're going to proceed? You can write like this: minus t square plus 10t plus 5 minus 6. Or you can write as t square minus 10t minus 5 minus 6. Or you can write as t square minus 10t plus x minus 5. Because t is the variable, so anything which is not t is a constant. So the x minus 5 itself is constant. And what we know that the maximum will only happen when t will have the unique solution, correct? So you will be here at one particular instant. There are not two values of t, right? So again, for x max, we can say that discriminant must be 0, because that is going to happen only once. And therefore, b square minus 4ac must be 0. So what we are going to get? 4x minus 5 is 100. So x minus 5 is 25. We'll take the positive value. And when we are going to learn the calculus, we can do by calculus method. That will be the third method. So whether you know the formula or not doesn't matter. If you know this process, you can solve entire kinematics with ease. So to become master of whether it's one dimension or two dimension, apart from the relative motion, of course, the relative motion will be easy for you if you know vectors really well. If you can play with triangle law really well. But most of the question of one dimension can be tackled only with the idea of quadratic. Okay. Seems that quadratic has become really difficult now. Huh? So are you finding the quadratic difficult? Really challenging or easy? Tell me guys, how many of you are finding it really difficult? Raise your hand. I would like to see. Prashansa, Rugved, Shreya, Siddhant.
No, sir, it's not hard.
So you are understanding the quadratic, the meaning of quadratic?
Yes.
Yes, sir.
So shall I believe that now you will not see quadratic as a mathematics? Rather, it's a way to attack some situation, or rather you can say it's a nice literature in which certain event can be captured. So the event in which one event occurs twice. The event may be the distance, height, time, and many more things. So you have to understand through the logic, like a quadratic is a way. It's like some sort of a method in which we bring the situation as a formula and then we deal with the formula. Okay, so I will expect that you guys will try to remember the quadratic. Quadratic can be taught to even greater extent, but there is no need to go so much deep in quadratic as of now in physics. Rest you will study in mathematics. Okay, so a little bit of coordinate is okay. I think little bit of coordinate. Coordinate geometry a little bit, not much. And I will be focusing on the straight line. In detail, the rest will be. So in a coordinate geometry, the first term is called coordinate. So coordinate can have multiple interpretation. So I'll keep the interpretation confined to the two-dimensional space. So a two-dimensional space, which is called a plane, and that's why it is also called the planar geometry, or sometimes it is also called the analytical geometry. So when we talk about the space can be one dimension, two dimension, and three dimension on a realistic scale. In mathematical term, space can be any dimension. It can be infinite dimension. But the physical behavior of dimension is only interpretable if it is either 1, 2, or 3. And every axis is nothing but representing a number line. So actually x-axis and y-axis are basically two separate number lines. And these two number lines are mutually perpendicular direction. So their direction is mutually perpendicular. And when we have two number lines which are intersecting at a right angle, we call Cartesian coordinate system. And it was first of all formulated by none other than Rene. You can say Descartes or whatever. Of course, these are French people, hopefully French or Italian. So he formulated this idea that, okay, let's cover the entire space in a two-dimensional world by drawing two number lines. And then every point in space is a reflection of value from each number line taken in certain fashion. So this point is actually representing one particular value taken from the y-axis. So this is a number, and we call it y coordinate. And the other reflection is this number, which we call x coordinate. So on the number line called x-axis, we have a number which we have taken x comma 0. And this is called y coordinate, which we write as 0 comma y. Which means the order is important. So this point is called x comma y. And x and y are called ordered pair of numbers. So what we call ordered pair of numbers. Numbers. And in this ordered pair, because why saying ordered? Because x, y, and y, x are not same. So by changing the order, we actually end up in a different quadrant or different location, if not quadrant, different location. So every point of space can be projected by taking two numbers. So let's say if I want to understand what is this point in space, so I have to look through the two numbers. One, by looking towards the x-axis, and if you look towards the x-axis, you will see some number. So whatever you will see is called the x coordinate. And if you look towards the y-axis, so this is the number you're trying to project. So what is xy? xy is the one ordered pair which we call coordinate. That's it. So meaning is simple. So the entire two-dimensional plane can be captured by just two variables x and y. And by properly taking the x and y value, I can reach any point in the space in a plane, of course. So when you go to 3 dimensions, then how many numbers we need technically to capture that location?
3.
So in the Cartesian system, we need 3. So in the 4 dimension, definitely we need 4 variables and so on. But the moment I will say 4 dimension, I cannot interpret, I cannot put into some picture. So there is no visual way to understand those things. So our confinement is only up to 3 dimension in terms of visual inspection. And beyond 3 dimension, everything is called abstract. So you will enter the world of abstract mathematics. And there is a branch of maths called abstract algebra, which deals with those high dimension things. Okay. So the first thing that we need to understand in coordinate geometry is locus. What is locus? Tell me guys, what is locus? Come on, this is not difficult. What is locus? So locus is basically collection of points. But are just locus a random collection? The answer is no. Locus is a collection of points which fulfills certain relationship. Okay. So it is a collection of points which fulfill certain relationship, or you can say constraint. So generally it's a collection of points which we call curve actually. Now curve need not to be like curved. Curve is a generic term in mathematics. So even a straight line is a curve. Yeah, don't get confused. A straight line is pretty much a curve. So you must have heard about the various things like circle, ellipse, parabola, hyperbola, straight line. Have you heard all these names? Or few of them? So how many of you have heard the straight line? Everyone or someone? I
Yes,
hope
sir, I
so.
got.
Anyone who has not heard the straight line? No. So if I ask you, what do you mean by straight line? How we are going to define it? What is the mathematical definition? Please don't tell me y equals to mx plus c. That is the most devastating answer. What exactly we understand when we say straight line? So can we say it's a collection of points? A line is a collection of points, isn't it? But even a circle is a collection of points. Ellipse is also collection of points. Parabola is collection of points. Hyperbola is also collection of points. Everything is collection of points. Every curve which we draw is a collection of points. So the biggest question is, if everything is collection of points, then how they differ from each other? So what really make them unique? The answer is, what really make them unique is the relationship which they follow, the constraint they follow. So the question is, what kind of constraint is followed by straight line? Tell me. No idea. So one thing you can say physically, that okay, straight line is the locus of point in which the point is moving in one fixed direction. You may say like that. But there is even more, you can say, mathematical definition. So what is the straight line? Tanisha will tell me what is straight line. How we are going to define, if we wish to define? Try, at least try. You all can try their definition and try to, I mean, like, try to really figure it out, that why we define the way we define and how it will help us. And it will take away all the effort, the effort of mugging up the formula. The definition is the way to arrive at the answer. And if you remember my first lecture, I told you that the way to approach science, not physics, science in general, is through definition. The definition will give you the sneak peek into the world of science. I mean, you can see through the definition how the world is designed, the world of mathematics or world of physics or chemistry. Anyone who wants to say something about the straight line? No. Hello, hello, hello. So no one is interested, huh?
So can we say that each point in the line, the theta remains same?
Yeah, very good. Very accurate. So we say that a straight line is a locus of point which moves in such a way that the slope of any 2 point remains same. Okay. So slope is what? Slope is tan of theta. So you said theta, which is again same as, either you say theta or you say tan of theta, is the same thing. So we can define like this. It is the locus of point. It's the locus of points such that the slope of any 2 points on the curve remains constant or remains same. That is how we start the world of coordinate geometry. It always starts with the definition. And once we have the definition, okay, now we need to understand what is slope. So first of all, we'll try to understand the slope. If we have a Cartesian system in 2 dimensions, and if I take 2 points, and if I call this the first point having the coordinate x1 comma y1, and this will have the coordinate x2 comma y2. So from geometry, from 2 points, how many line can pass? How many line can pass from 2 points? Am I audible? Hello, hello, hello. From 2 points, how many line can pass? Exactly 1. So that's a definition in geometry. If you have studied class 9th or 10th geometry, this was some of the theorem. Okay, so to find the slope, you join the points, and then you draw perpendicular from the given point to the x and y axis. And this point is nothing but the 0 comma y2. This is x1 comma 0. And if I call this angle as theta, and if you extend this line further, the slope is defined as, anyone idea how we define the slope? We define the slope by taking the tan of the angle made by the positive x-axis. So luckily this is theta because of the corresponding angle relation. And in this triangle ABC, because it's a right angle triangle, can we write tan theta? So tan theta will be BC upon AC. And what is BC? It is clearly y2 minus y1. What is AC, guys? This is the definition. This is called slope in math, physics, history, chemistry, everywhere. So when I say slope, I'm saying tan of angle. And in mathematics, we prefer to represent a slope as m because it is convenient. So basically, m is nothing but okay. Hello, guys.
Yes, sir.
Am I audible?
Yes, sir.
Okay. So now when we say slope, then we mean all these things. So you can write by a symbol m, you can write tan theta, or you can write, if the points are given, you can express further. But we are trying to find the equation of straight line. So multiple things they might give you, okay, or multiple forms are there actually. So the first famous form is called, the very famous is called 2-point form. What does it mean? The line given is passing through two known points. So if you know already that the line which I'm going to draw is passing through these 2 points, and if you know the coordinate of these 2 points, let's say x1, if these two are a finite or fixed point, so how to write the in a general point? So the general point we have to write by the general symbol x and y, correct? And the locus is nothing but the finding the relation between these two variables. That's called locus. And the locus always, when we obtain the locus, it always comes in terms of some expression which we call equation of that locus. So what is the definition? Tell me. What is the definition? Come on, what is the definition of a straight line? The slope must be constant. So the tan theta we can write in two ways, either in terms of y1 or y2, x1, x2. Or can we write in terms of this and this point, the bigger triangle? And if you write in the terms of bigger triangle, how we are going to write? Tell me. Tell me, guys, please.
X minus x1 upon, sorry, y minus y1 upon x minus x1.
And if you take these two parts separately, in math, this is called 2-point form. That's it. Y minus y1 equals to y2 minus y1, x2 minus x1. So this way of writing is given a name, 2-point form. What a big deal. So when you know the 2 points, you can express the answer. And because y and x are in a general value, so it means if you give me x, I can tell you y. That is the meaning of equation. So given x, I can tell you y. And what I need is just 2 points. But as I said earlier, we can also write this as m. Okay. So the same formula we can rewrite as y minus y1 equals to m times. So if you write like this, what we call? So y1, x1 is representing 1 point. And m is the slope. So what is the name of this way of writing?
Slope point formula.
Slow point form.
Excellent. Is it difficult when all are simply ways of writing? And are we really trying to write this by mugging up, or we have the logic? What is the logic? That any 2 points on the straight line will give you the same, same slope. And through that definition, we are deriving it. Okay. Now the famous one is what? Point intercept form. Hai? I hope you have heard this name. Point intercept form. So what is the intercept? What do you mean by intercept? Tell me, guys. No idea. No? Intercept is where the line meets the y-axis. So let's say the line is meeting the y-axis here, and the distance of the point from the origin is called C, and C is called intercept. A positive C means the intercept is on the positive side of y-axis, negative means negative side, and 0 means the line is passing through origin, isn't it? Hello, hello, hello. It is clear, guys? Tell me.
Yes, sir.
So, because we don't know the answer, so first of all, can we write the coordinate of this point as 0, comma C? Right? So we know a point and we know the slope. Let's say M is the slope. So can we use the point slope form? So use the point slope form here and get your answer. So what you write? Y minus y1. The only point which we know is 0, comma C. So what is y1 here? The value of y1 is C, equals to M into x minus x1. What is x1? What is
0.
x1? So if you look carefully, this is nothing but y equals to mx plus c. Every formula is derived from the first definition. And once you know the definition, you can keep on deriving. So these are the ways of writing the same thing in different symbolic notation. So what is the next one?
So can you go back to the previous question? Yes, sir, thank you.
Tell me the other form which you have studied. The next one is called double intercept form. Have you heard this name? Tell me, guys, have you heard this name? Yes or no?
Yes, sir.
So what happens here? The line will cut the x and y axis both, and luckily you know both the point of intersection. So this point we call a comma 0, and this point we call now 0 comma b, and a and b are called intercepts. So which form of equation will be best way to get the answer of this line? Because you know the 2 point, can we use the 2 point form? Or because we know the y-intercept and we can calculate the slope, we can use the slope point form. What is the best way to derive the formula? By using, hello, hello, hello.
So we can use either of the method.
Yeah, so use anyone and tell me the answer.
So
So
then
use,
2.0.
yeah, you use any one of them and tell me what you are getting the answer. Once you derive it, you are a master of the straight line. You know how to produce the equations.
Sir, M is equal to minus B by A.
Yeah, that's fine. But I'm asking what is the m is minus b by a is fine. So which equation you want to write? Which form you're using to get the answer?
Sir, 2 point.
2 point. Oh, so then m is not required. You can directly do it. So you have the 2 points a0 and 0b. Everyone, please apply the any of the form which you have learned so far and tell me the answer. I'll wait for the answer. What happened, guys? Why it is not possible? If 2 points are given to you, you must be able to write the relationship. Is it so difficult? Hello, hello, hello. Anyone, please try to derive the formula, the relationship of x and y.
Yes, sir, I think I got it.
Tell me.
Sir, X by A plus Y by B is equal to 1.
Excellent. Very good. So which form you used? 2 point form.
Yes, sir.
So tell everyone that what you wrote. So what is your x1 y1?
Yes, sir. First, I took Y1 as 0 and X1 as A.
Okay, okay. So you choose this as x1 y1, right? And you took this as x2 y2, right?
Yes, sir.
Then what you did next?
And then just use the point slope formula.
Point slope or double point form? Which formula?
Sir, point slope points.
So okay,
So
fine.
first I
Yeah.
found slope minus B by A, and then
Very
I
good.
substituted into.
Yes, you can go ahead.
Substituted M.
What is y1 here?
0
What is m here?
minus B by A.
What is x1? So y equals to minus bx upon a plus a. So y plus bx upon a is a. Sorry, b. So minus b by a into minus a will be minus plus b. And then rest is simple. So y by b plus x by a equals to 1. Or you can read it the way he said. In a straight line, you're not supposed to remember anything. Just know the definition, remember the basic formula, try to create some points, write the answer. It's very much simple. But knowing all this format will just speed up the process. If you know that I can write this way or that way. So given what is known to you, you can use it and you can get the answer. Let's see how these things are so much popular in physics. So let's say there is a heater in some room. It's a winter in some city, and so there is a heater. And as you move towards the heater, the temperature will increase, yes or no? Okay. So if I call the x as the distance from where you start moving, and if I choose the y-axis as the temperature, so wherever you are standing, let's say where you are standing is the location called x equals to 0. So at x equals to 0, the temperature is found to be T naught. So how to write 0, T naught? Assuming the variation is linear, which means the temperature is increasing linearly. And it is found that after traveling L distance on the x-axis, the temperature which you observed, that answer is 2 T naught. Okay. So if you are here at a location X, it must have some temperature T. So the obvious question is, can you find that temperature relationship with X? What is known to you here? The thing which is known to you is the temperature at x equals to 0, temperature at x equals to L. What is given to you as information? That the variation is linear. So every linear variation is called a straight line. So I'll come to the physical meaning of straight line. A straight line represents proportional behavior, or the linear behavior, or you can say the linear relationship, proportional behavior. So the y and x, y means y axis variable and x means x axis variable. Luckily here the x axis variable is x, but the y axis variable is now given a new name t. So you are supposed to find the t as a function of x. We'll do this, everyone. The difference between knowing mathematics and applying in physics. And if you're not able to apply in physics, I'm very sorry. There is no purpose of mugging up maths. Please, everyone, tell me the answer. These are very small practice, but once you're good with this practice, you will realize later on that you can attempt any challenging problem of physics because you know the right mathematics in the right way. So because x is a general point, some random location, it must have some random value t, and that's how you get the equation. Are you guys doing this question?
Yes, sir.
Please everyone try and try to get the answer. Yeah, tell me guys. Got the answer? Hello, hello, hello. Hello, hello, hello.
Yes, sir.
What happened? You know straight line. You know the multiple forms of right line. And what I have shown you is the a piece of a segment of line, right? You can extend the line. So this line is a part of the bigger line like this. So how to get the equation of a line? So which form is best way to get the answer? So what is the coordinate of this point? Tell me. The coordinate of this point is how much, guys? Tell me.
L comma 2 T0.
Very good. And this point is how much? This point is how much, guys? Tell me.
0 comma T. No.
That's it. So if you know the 2 point, why you get like worried? You know what to use when you
So we
know
have
the
to
2
find.
point.
We have to find T in terms of T naught,
X.
X and L, na?
Yeah, of course,
Three.
of course, of course.
Then I found it.
Tell me.
The T is equal to T naught bracket X plus L upon L.
Like this.
Yes, sir.
I think this is the right answer. So how many of you are getting this answer? Please tell me. See, if you're getting confused, please do let me know. Then only I can explain. No? You're also silent, not doing anything. Then how I'll come to know whether you're getting or not? What is the problem you're facing? Prasansa, what happened to you? Why you're not getting the answer? Tell me. If you haven't got the answer, tell me why you haven't got the answer. What is happening?
Sir, I wasn't able to figure out how to write the coordinates.
Oh.
0,
Look
comma
at
T
the-
naught.
Look at the x-axis, look at the y-axis, and see what is the value there.
So once you said it, it became very easy. I wasn't able to figure. on my
Yeah, so that is one problem. It's really good to know. So anybody else share why you are not getting the answer? Are you there? Shreya, are you there? So why you didn't get the answer? Tell me. And Rugved, you tell me what happened with you? Why you were not getting the answer?
Sir, I was not able to see how we would proceed.
Yeah. So you need to find at least 2 points, and once you have 2 points, you can always use the 2-point form. That is the best way to approach. So the way of writing is, you know, one formula: y minus y1, y2 minus y1, x2 minus x1, x minus x1. Just remember this way. Okay. Now you can name anyone as x1, y1, x2, y2. It doesn't matter which one you name. It really doesn't matter. I can choose this as x1, y1. It really doesn't matter the way you assume. Anything, just assume anything. What is y here, guys? Tell me. Can I write y as t? Because I have chosen a variable t for the y-axis. So the y is t. What is y1? Just look at the value. What is y1? 2t naught. Fair enough. What is y2? T naught. What is y1? T naught. What is x2?
0.
0. What is x1? L. X minus what is x1? X1 is
L.
L. So we are done. So t equals to 2t naught plus minus t naught by L. This is t naught by L. So it really doesn't matter how you proceed, you get the same answer. Also, what doesn't matter, which one you choose as x1, which one you choose as x2. But make the process correct. Once you choose x1, y1, x2, y2, And when you're writing it, you write in the same sequence. And if you do so, you will get the answer. Similarly, let me show you some other formula. One more last. I hope you must be tired today, you all. So if I draw something like this, so you might have heard about the Ohm's law, right? So there's something called resistivity, or maybe I can talk about density. So they said density we represent by a Greek symbol rho, RHO. So generally we represent the rho for the density term. And the density is changing with a variable called radius. So this is a formula for a sphere. So in a sphere, as you move away from the center by distance r, the density is changing. Density is changing. So at the center, the density is rho naught, and at a distance r, the density is rho. And the variation of the density is shown in the figure, like this, or maybe like this. I will write like this time. And if the sphere is having the radius capital R, so when R is R comma 0, density is 0. And when R is 0, the density is rho naught. So what is the relationship of rho versus R? If R means function of R, don't worry, you will study this in detail in calculus. So can you tell me the equation of this line? What is the relationship between rho and R? Of course, in terms of rho naught, capital R, and so on. So you can look carefully. This is the straight line. And if this is the straight line, it means we can write the relationship. So please tell me what is the relationship. And if you're getting again confused, you can ask me, I'll explain. But try this out. The method is almost similar, no matter which question I give you. What you need to understand that if it is a straight line, it will follow the 2-point form, slope intercept form, point slope form, double intercept form, or what is this? Yeah. There's one more which I haven't discussed called parametric form, but that is not required in physics. So parametric form is again interesting.
So rho naught is the distance from the origin.
Yeah, rho naught is the value of the y coordinate.
Yeah.
Very good. And it is a constant. So when I use the naught, it is generally to represent the constant value. And the rho is a variable. Okay. Okay, what is the best way to get this answer? Which form is the best way to get the answer?
So can we get it by double intercept?
Excellent, very good. Because it is visible to us, no? We can see directly. So what we should write? The x we have replaced by r and the y we have replaced by rho. And what is the double intercept form? X by a plus y by b equals to 1. So tell me guys, what should I write here? Whatever you will tell, I write.
For small r by capital R plus rho by rho naught equals to 1.
Excellent. And therefore rho by rho naught is how much? 1 minus r by r. So rho is how much? Rho naught 1 minus r by r. And these are very famous formula in when you will study physics in class 12th, also in class 11th also. You'll come across all these formula. And knowing the relationship and its meaning is really important. So if I give you any straight line, can you get me the equation? The last problem. Okay. And this is again the one of the most challenging problem from physics. So the red is representing some segment of a big line. P is called pressure and V represents volume. P is called pressure, V represents volume. And the values are written in terms of symbol as V naught and 3V naught, P naught, 2P naught. So what will be the equation of this line? Of course, equation of line for which the segment is a part of. So I want to know the equation of line, or you can say what is the relationship between the pressure P and the volume V which lies on this line. Please try this out carefully. It's not difficult. Try this out. Everyone. For every challenging problem in physics, the first step is writing the equation. And many students, they fail to write the question. Why? Because they know the linear equation, but they don't apply in physics. So I decided that, okay, no, in my lecture, until you will not learn to apply, I will not leave. I'll keep on giving you question. You prove that you have learned, I'll go to the next topic. Else, the torture will continue. All right, guys, tell me the answer.
Sir,
Hmm.
sir, actually I have class in at 9 o'clock.
Yeah, I
So
know.
sir, I have to have dinner and
You have to leave and you have to have dinner, but this question will be homework then.
fine, sir.
Yeah, all right. So I'm giving one more question, which I will just put it here. You can see later on in the PDF and you will solve. So those who want to go, can leave.
Fine, thanks, sir.
And yeah, you can leave. I know. I think Shreya should also leave. Okay. Imagine if we have a relationship between a symbol I and T. The I is called, let's say, current, and T is called time. And the equation is like this. So how many straight line you can see here? Tell me, guys.
2.
Where? So now you are supposed to write the two separate equations for each line. To make it nicer, let me call I. So these are your homework. Here you have to find the time equation of both lines. So you can say 1 and so 1 and 2 are not the same line. So actually this graph represents two separate straight lines, and therefore you will get two answers. Okay. So with these two questions, we can stop today's lecture. Now those who are having still some doubt or any difficulty, you are free to ask. I am here. Prashansha, Rugved,
No, sir. Not.
Shreya, Tanishi, you have doubt? Are you there? She is not there. All right. So let me stop today's lecture and we'll continue. So okay, we are very close to the actual part, which is called calculus. So certain things I'll expose is called binomial theorem and binomial expression. And are you guys okay with exponential and logarithm? Hello, hello, hello.
Yes.
So if you have already studied in mathematics, then I will skip the exponential or logarithm. Or you want some input from that also?
Yes, sir.
You want input?
Yes, sir.
All right. So I'll teach you the logarithm and exponential also. So the topic which is left is now exponential, logarithm, and what? Binomial, factorial, the idea of factorial. And yeah, I think after that we are good to go with calculus. So maybe one more lecture I'll take to finish the prerequisite of calculus, and then we'll jump to the calculus. We'll start with domain concept, range concept, limit concept in a very brief manner, of course. You will study those things in detail in class 12th maths called LCD, the limit, continuity, and differentiability. Right now, I need a small part from everything, so I'll teach you a very brief introduction of all those things. Very much realistic. It's easy to grab because you can actually see it. It's not very difficult. So you can have the visual perception, everything. And yeah. So hopefully, as soon as we enter the calculus part, after the first lecture, probably I'll start the kinematics. All right, guys. See
So
you
what
on-
is the answer of the pressure and volume graph?
You got the answer? You got the answer?
So I'm not sure about my answer.
See, can you find the 2 point first? See, to find any point, we need to look for the x and y coordinate. What is the x coordinate of this point? So check the x-axis. What is the value?
V0.
Very good. Simple.
So I'm getting the answer as P0 V plus 2P V0 equals to 5 P0 V0.
Yeah, that may come. That's not right. So what is the coordinate? Tell me the coordinate. V0 and
2 P0.
very good. And for this point, what is the coordinate?
3 V0 and P0.
Very good. So you can use the 2 point form.
Yeah, I
So,
used that.
so first of all, you can name it. Let's call this as x1, y1. Let's call this as x2, y2. Always begin like this. You assume something. Once you have assumed, then write the equation. y2 minus y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1. So what is the formula you have to use? And simply substitute one by one without getting worried. Just substitute. You will get the answer. Because you are asking, let me tell you. So y, what is y? P. What is y1? 2p. What is x? Tell me, what is x? What is x?
V.
X is v. What is x1?
V naught.
Very good. Yes. What is y2?
P naught.
What is y1?
2P
2p
naught.
naught.
Very good. And what is x2?
3V naught.
And what is x1?
V naught.
P naught.
You are done. So p minus 2p naught upon v minus v naught is basically minus p naught by 2v naught, right? And 2p naught minus p naught by 2v naught v minus v naught. So if I rearrange minus cancel. 5 p naught by. Yes, 5 p naught by 2 was the right. Someone told me this answer. I think this was the answer, right?
Yes, sir.
And this is the right answer. It may look weird to you, but that's the right answer. And for the current part, you have to do this twice. So you need 2 point for this line. So you can take origin and this point. And 2 point for this line. So you can take this point, which is common for both. And again, you can use the 2 point form again and again to get the answer. So no matter what is written in the y and x axis, you have to think in terms of straight line. You have to search for 2 points. And once you have those 2 points, apply the basic formula, get the answer. That's it. Understood, everyone?
Yes.
And see, these are not simple. What you are doing is not simple. These are the first step of all challenging problem in physics. And if you don't get the first step right, how will proceed? Okay. So straight line, you must have studied. Physics will give you the opportunity to apply it. And therefore the understanding is important. Okay. So maths and physics will go hand in hand. And we cannot see both in isolation. All right, with this all torture, we can end today's lecture. Urugved, you have doubt?
No, sir.
You understood everything?
Yes.
Very good. Excellent. So, all right, let me end lecture. You must go. Why you're waiting here? I just told you, you can leave. I know that you have lecture.
Thank you, sir. Bye.
Okay, bye. Take care.